Hey guys, welcome back. This is Matt Lockney with LumosConsulting. We're going to talk a little bit more about ACI today, specifically around application-centric model ACI versus network-centric model ACI. A lot of questions we get either when we go on site to do our customer deployments, or even if we're working with a partner who may know a little bit more about ACI in general, they still kind of get hung up on this idea of NetCentric versus app-centric models. What are the pros and cons of both, and maybe how do we get from one to the other? We're going to talk today about specifically the kind of pros and cons and the different approaches to networking that these models take. So let's go over what we're talking about here. So the first one we're going to cover is on the right-hand side, the network-centric model. So what we're talking about is one endpoint group. Remember, an endpoint group is simply a group of endpoints that are treated to a similar policy model, whether that be QoS or whether that be some kind of VMM attribute that we're applying, or even an ACL, right? And in most cases, we're talking about ACLs when it comes to ACI, because the thing that EPGs are good for is for that whitelist communication model where we need to talk from one EPG to the other. By default, we have to have a contract in place. So the next thing is the bridge domain, right? So one EPG per bridge domain. Our bridge domain is our layer 2 boundary. It can also encompass layer 3 boundaries. And in most cases of what we're talking about in ACI, it probably does. So in network-centric, we've got one EPG per bridge domain, and then one bridge domain and EPG combination per traditional VLAN. Okay, so this is what we term traditional networking. So if we look at the picture down on the right-hand side, we've got a bridge domain set up. It's called VLAN 10. We've got a subnet IP that's attached to that. So the SVI for that IP might be .1. It's going to be a smaller subnet generally than what we would use in our application-centric, because we're doing the same kind of functionality that we have in our traditional network modes, right? And then the endpoint group that's attached to that bridge domain and subnet is going to be, simply VLAN 10. So it's going to be the same kind of one-to-one-to-one relationship that you'll see for all network-centric endpoint groups and bridge domains in ACI constructs. When we talk about application-centric, we're talking about something a little bit different here. So if we look at the picture down at the bottom left, you'll see that we have the idea of these different tiers that we talk about. These tiers are going to be our endpoint groups, but they don't necessarily have to be in their own subnets. So here we've got an external user group, so that's where our web browser users are sitting. And between the external network and our internal network in our web tier, we're going to have a contract. That contract may allow, port 80 and 443, that allows our external users to hit the web server, the Apache's daemon on that web server with their web browser and get a response. And then between our web tier endpoints and our app tier endpoints, we're going to have a different set of rules or contracts that allow communication between those endpoints and those groups. And this might be something like, port 8080 that's used for the application port, or something else. And then again, between our application tier and our database tier, we might have a completely different set of communication requirements. So this might be using, SQL ports or Oracle ports or something else, right? And maybe at this point we have some, bidirectional flow going. So the idea is we can have many different endpoint groups, but the bridge domain in this picture is the same. Here we represent it as an application network profile, which is an organizational container for endpoint groups, but the underlying bridge domain is going to be the same bridge domain for that. We specify contracts between the endpoint groups, even if it's an IP-any contract, and this is what we term modern networking. So we have a lot more flexibility of security in this model than we do in the network-centric model. The big thing here is that we don't have to choose one or the other, right? We can run both AppCentric and NetCentric on the same ACI fabric, even in the same tenant or VRF space. Remember, a VRF is just another way of saying IP routing table. So let's look at NetCentric and kind of what that means, how it relates to our traditional networking constructs, and then how we, why we see it so often. So the first thing is let's review kind of our traditional networking hierarchy. So we've got this core aggregation access layer model that we've been using for decades now. We've got our layer 2, layer 3 at the aggregation or distribution layer. So this is where our SVIs live. So the .1 addresses for all of our hosts down at the access layer are going to live here at that access layer or at the aggregation layer. And then inside of that access layer that we create, we're going to be doing things like some kind of STP mitigation, so either back-to-back VPCs maybe, or some kind of multi-chassis link aggregation to avoid STP blocking topologies. And then down at the access layer itself, we've got many small isolated layer 2 domains. So these would be our VLANs in our traditional network. Generally, they're going to be /23, /24. If you're feeling really brave, you might do something like a /22, but really that's probably as big as they're going to get down at that access layer in our traditional networks. So when we get to our ACI fabric, we have, you'll notice a little bit different topology. We're doing a leaf spine instead of our traditional 3-tier. But a lot of the things are going to be the same, right? So we're still doing a underlay fabric running no STP in this case, right? So we're trying to get away from those STP blocking topologies that we've been using traditionally. And inside of our logical constructs within ACI, we're going to create those logical constructs that we had in our 3-tier, right? So we got a couple of different terminology that we use, but basically it's the same. So tenants, remember these are just a kind of organizational container unit, and then VRFs, which are our IP routing tables. And then inside of that, we've got our bridge domains, subnets, and EPGs. Those are what we're going to be talking about today because those are what we relate specifically to network-centric. So our bridge domain, again, our layer 2, layer 3 boundaries. Our subnets are where our SVIs live and where we designate the IP addressing for that particular bridge domain. And then our endpoint groups are hosts that are treated with a like policy model. So here, bridge domain, subnet, EPGs, we have this one-to-one-to-one relationship. So one traditional VLAN in our legacy model equals one bridge domain, one subnet, one EPG in our ACI model. And then finally, if we're doing VMM integration, we also have one traditional VLAN is going to equal one vSwitch port group. So when we create that EPG, this is VLAN 10, we're going to create a port group down on the vSwitch that also says VLAN 10. So the same thing that we've kind of always done for our networks that we're kind of working into this idea of ACI. If we expand this out further and we start looking at actual IP addressing and how these VLANs tie in, so we've got here our 3-tier design again from the distribution layer down, and we've got 3 VLANs identified, 10, 20, and 30. They each have a network address and mask, and each one is going to have an SVI address. This SVI address is going to live on the switches as needed, but the idea is no different when we get to the ACI side, right? So we talked about how we're going to need a tenant and a VRF. Right, so we've created our tenant coke, our VRF1. Now we need to recreate that same VLAN ID and SVI and mask inside of that in bridge domains and EPG format. So very simply, we create a bridge domain, VLAN 10. We give it a subnet IP of 10.1.10.1/24. We select the application network profile, VLAN 10, and under that we create the EPG VLAN 10 and we link it back to our bridge domain. So this then creates that one-to-one-to-one mapping that we talk about when we talk about network-centric. If we want to scale this out, it's very easy because we just take this as a template and we apply it to VLAN 20. So here we create our bridge domain, our subnet, and then our application network profile and our EPG. Same thing with VLAN 30 and so on and so forth. So looking at some of the pros and cons of NetCentric, the pros are it's very easy to implement and migrate, right? This is exactly what we've been doing in our traditional networking for a decade now. Nothing has really changed, right? We don't need any special knowledge of our applications. Our firewall rules still work the same way they always have because it's still based on IP addressing. It's the closest thing that we have to traditional networking constructs. The cons of network-centric are it's a very traditional security model. If that is not enough for you, and you want something that's a little bit more east-west flexible within the data center, then you probably want to get away from network-centric and move towards app-centric. It also gives us lower design flexibility because each of those VLANs themselves is where the endpoint lives, right? The endpoint group. So we can only, unless we're doing some sort of intra-EPG isolation, we can only enforce contracts between different VLANs. So if I'm using /20, for VLANs, that entire EPG is using the same contract to talk to the next EPG and as every other host in there. Then we have reduced opportunity for advanced features. So because, again, we're doing contracts between endpoint groups, this is where we would attach things like service graphs or contracts between them. So less flexibility, less opportunity to do those kind of options that enhance that security posture. The last thing is it's IP dependent, right? Because everything is still based on VLANs attached to subnets. So those subnets don't change. This may be a good thing for our server guys because they don't want to change IPs, but it becomes a pain for us as a network team to manage and distribute these IPs and have to come up with some kind of IPAM solution, whether that be Excel or whether that be Infoblocks or whatever the case may be. Somebody's got to maintain and track that information. So let's look a little bit into application-centric. What are the differences, and then what are the benefits of moving towards that kind of model? So the first thing that we're going to see as we go through this is our tenant and our VRF structure is going to remain exactly the same, right? So no change. So here we have tenant Coke, VRF1. When we get to the bridge domain, this is where things kind of shift a little bit. So here we create our bridge domain BD Coke, and we create a subnet address attached to it, just like we did in our network-centric model. But we're doing all kinds of optimizations at layer 2 in ACI so that we can make these subnets a little bit bigger and not have to worry so much about IP addressing. So in this case, we're making the subnets from like a /24 into a /22. This could be a /16, honestly. There's no reason why we would have to limit it because we're already doing the optimizations on BUM traffic and ARP, broadcast traffic, ARPs inside the fabric itself. So we create this larger bridge domain, first of all, and then we're going to go ahead and start adding in our application network profiles and our EPG containers under that. So here we've got our application network profile Coke, and we say underneath of that we have an endpoint group called web tier, another one called app tier, another one called DB tier. They will all use that same IP addressing, but they're going to have different policy applied. The next one is going to be our application network profile Sprite. It's also going to have a web app and DB. And then the final one is going to be Coke 0 with the web app and DB. Now this could be same tiers, it could be different tiers. We could have lots of different, mix and match. There could be 10 tiers in Coke 0 and 2 tiers in Coke, right? It really doesn't make a difference. What we want to do, though, is be able to separate these policy groups out in a meaningful way. The other thing is I can now click on my application network profile Coke, and I can see a representation through either health scores, faults that are related to that application, of the entire application itself, all of the different tiers and all the different communication layers that are going to happen that I've designated as part of application network profile Coke. I now have a single point of view. I can click on that and see an overall health score and how it's doing. So we've got our endpoint groups defined. Now comes the magic, right? So now we're able to apply contracts. Remember that by default, ACI is a whitelist model. So between different EPGs, we need to specify contracts that allow communication. Otherwise, they can't talk by default. So here's where the red lines come in. They represent our contracts. And here in between our web tier and our app tier of Coke, we may be using different ports that we're using between our Sprite and app tier and web tier, right? And that may be different ports between our Coke 0 web and app tier or web and DB. These contracts could also go between the different application network profiles. So we can have a contract that allows, from our Coke DB to our Coke 0 DB, for example, however you want to break it up. We can even allow different contracts out to the outside world. So here we represent our 0/0 route going out to the outside world, and we say that port 80 and 443 are going to be open on all of the web tiers, but we're not going to allow our external users to get into our app or our DB tier. There's just no reason for that. But we have our dev guys or our application maintenance team that needs access to the app and DB tier. So we create a specific contract for those users or that subnet that allows those guys access into what they need to get access to. So a lot of flexibility, but we can go even further. When we create these EPGs, we're going to assign a VLAN tag or IETF VXLAN or even an NVGRE number to each of these endpoint groups. That in turn, if we're doing VMM integration, is also going to translate into a one-to-one mapping down on the vSwitch port group. So if I'm a vCenter admin and I go in and I'm creating a new database server for Sprite, I go in, I look at, I select the VM guest, I go to the VNIC tab, and out of the drop-down box, I see Tenant Coke, Application Network Profile Sprite, and EPG DB tier. And I know that that's what I have to select for my VNIC to work properly. So it makes things very easy for our server guys as well. But it doesn't stop there. So the next thing we can do is, because now we have contracts in place, we can add some additional services on top of that. So not just the port filtering contracts that are available in ACI as part of that whitelist model, but let's say I want to do full deep packet inspection between my web tier and my app tier. I can insert in that contract a service chain that says, hey, if this contract is allowed, send it to the firewall first. And then between my app tier and my DB tier, I say I want to do load balancing. But I don't have to do one or the other, right? I can do a service chain with multiple graphs on there. So I can say between my web and app tier, if I have traffic that is allowed on that contract, first send it to my firewall. If it passes the firewall, send it to a load balancer, then allow the traffic to continue and also copy it off to my IPS module so that I can, make sure that the traffic is actually doing what it's supposed to be doing. So this gives us a lot of flexibility, not just with the contracts, but with the additional security features that ACI offers. And this could be managed mode, this could be unmanaged mode, this could even be PBR. So policy-based redirect as of 3.1 is available as an option. So pros and cons for application-centric mode. The first one is application security can get very granular, as tight as you want it. It does full enforcement of the application communication in a very DevOps style security model, right? So it's based on the application and tier rather than an IP address, right? So IP address is not necessarily as important because the policy is going to follow the host, not the IP address. Obviously, that gives us a superior security model, and then high design flexibility. So we can do contracts, we can do service insertion, and then application level visibility. Like I talked about, I can do a one click to see what the application health and status is just from a single click of my GUI. The cons are, because we're doing full enforcement of application communication, it requires a greater understanding of how the application communicates. We actually have to know what this application talks to at any given time so that we can allow those contracts to take place. We can do, some workarounds. We can say, basically IP any, allow between endpoint groups. But at that point, we haven't gained anything over our traditional security model. In fact, maybe we lost something because we were punting it through a firewall before, and now we're not. So we need to be very careful about how we're addressing that security, point of view. The other thing is, converting from our traditional network can be very labor and time intensive. Somebody has got to be able to, define what those communication requirements are, whether that be through looking at firewall logs, whether that be talking to developers, and actually putting those requirements down, converting them into ACI. Generally, we're going to require a new IP scheme because we're talking about doing bigger bridge domains so that we can fit more endpoint groups in a single bridge domain. And then this, of course, requires more time for migration. So if we have to take all of these security requirements, convert them into ACI, and we're going to do IP migrations as well. Generally, we're looking at a longer time. But again, the good news is we don't have to do one or the other, right? We can do both models at the same time, and we can separate these out by tenants, by VRFs, or even just bridge domains, which is probably the most popular method that we see. So let's walk through a couple of those and see how that looks. So here we've got an application network-centric deployment, both separated by a tenant. So we've got tenant coke, our VRF coke, and then we've got our bridge domain VLAN 100, our subnet address, our application network profile, and our EPG fall under that, right? VLAN 200 has its own subnet, its own EPG. So this is our network-centric model. In tenant Pepsi, we've got our Pepsi VRF. We create a larger subnet address, so /22. And then underneath of that, we've got our application network profile Pepsi and Pepsi Max, which have their own endpoint group tiers. So web, app, DB, contracts in between the tiers, possibly contracts in between the application network profiles as well. So this gives us that a logical separation at a tenant level rather than just at the VRF or bridge domain level. Perfectly acceptable to do this. If we're going to break it down into a single tenant but different VRFs, this would be another popular way of doing this. So here we've got our tenant coke. Our VRF coke is going to be the network-centric deployment. So we've got our bridge domain VLAN 100, bridge domain VLAN 200 with the matching EPGs and subnets. On the other side, we've got our Sprite VRF, which is going to be our application-centric deployment. We've got our AMP Sprite, AMP Sprite 0, each with its own endpoint groups and contracts. Separated by bridge domain, like I said, this is probably the easiest option for most of our customers who are choosing to run both application-centric and network-centric, because they don't have to worry about doing VRF leaking or sending out and letting another device route between these two. That may be desirable, but in this case, it's very easy. We create one tenant, we create one VRF, and then inside of that, we have our network-centric bridge domains, VLAN 100 and 200. They're both /24s, and they have a single EPG dedicated to them. For the application-centric side, we have this bridge domain coke, which we're going to make a /22, so bigger in nature. And then we've got our EPGs with our contracts between them. And again, we have all the benefits of doing this, single visibility, more granular security, application level visibility, all of the benefits of doing the AppCentric with side by side with our traditional networking that's going to maybe move. So I hope this explained a little bit better about AppCentric versus NetCentric, what the benefits are, and maybe in the future we'll look at having some more videos on how we actually migrate from that network-centric mode to application-centric mode. Everybody seems to start out in that network-centric, but they kind of get stuck there. So thanks for joining today, guys. Hope this was beneficial, and Matt Lockname with Lumos signing off.